Hello, this is your lazy dev and welcome to my YouTube channel. In our previous video, we have learned how to implement different HTTP endpoints, that is HTTP GET, PUT, POST and DELETE using dummy data. That means we did not had any kind of database, we just used a list of data which we just retrieved. So the data was not stored anywhere, it was just a random data that we created each and every time we started our API. In this part of video, we will be going to learn about how to connect our API with an actual database. We will be using MongoDB. MongoDB is a type of NoSQL database. You might be aware that there are two kinds of database, SQL as well as NoSQL. SQL databases are nothing but a relational database where the data is managed or stored in the form of tables, that is rows and columns. On the other hand, NoSQL database is of four major types, that is document databases, key value database, wide column stores or graph database. MongoDB falls under category of document database. Here we do not have any kind of rows and columns. Each and every record is present in the form of document, which is nothing but a JSON object. So we get more flexibility to store our data. As we know, JSON object can have multiple list of key value pairs. In relational database, the restriction we had is we had to store the data according to the number of columns. For example, if one particular record has an extra field, then to accommodate that particular data, we need to add one more column. That particular column may be useless for the rest of the records, but for having that one extra data, we need to add an extra column. That is the limitation of relational database. So that's the theory about NoSQL database and MongoDB. Now to connect with MongoDB, first we need is the MongoDB server. If you go to this particular link, which I'll be providing in the description of this video, you can download MongoDB community server. Once your download is completed, just execute the file and you'll land on this setup screen. Just go ahead and click next, complete installation, click on next, and here you see it will ask you an option to install MongoDB Compass. MongoDB Compass is the official graphical user interface for MongoDB. There are other alternatives for this like Robo3T. If you are well aware of those tools, you can go ahead and install them. For now, we do not require neither this MongoDB Compass nor the Robo3T. I'll show you why. Let me go ahead and click on next and install. Once you're done, click on finish. Open command prompt, cd program files, MongoDB server, cd 5.0, cd bin. So if you see here, there are three different executable files, mongo.exe, mongod.exe and mongos.exe. Right now we will be using only mongo.exe. So I'll just type Mongo and press enter. Here we go. It connected to our local MongoDB server. So you are inside the database. To know the set of commands, you can just type help. So here are the list of commands that you can use on your MongoDB server. For now, I'll try to see what all databases I have. Show DBs. So these are the initial three databases that comes by default when we install the MongoDB server. Now if you want to create a new database for your application, the procedure to do that is use database name. We will be using the database name as tasks database. It says switch to DB tasks. So it has created a database named as tasks. Let me show you another thing. Once you start using that particular database, then the DB keyword, the DB variable, which is default variable of this MongoDB, it holds that particular value, that is tasks. So the next command I will be displaying you is show collections. Right now we do not have any collections. Collections is nothing but the tables in our relational database. So here we do not call them as tables, we call them as collections. Collection of documents. So if we want to create a new collection or a new table in MongoDB, the procedure is similar to what we have done for the database. For database, there is no specific command to create a database. We have just tried to use a database which does not exist at all, and it has created that database automatically for us. The same thing applies for collection as well. So db dot, I'll do a test collection dot, the command to insert a record is insert one, and the fields, it should be a JSON document. I'm sorry, it should be camel casing. Done. It says acknowledged, inserted ID is object ID. So if you observe here, I did not specify any kind of primary key. db dot test dot, to display all the records we have, the command is find without any arguments. Then it will act as select star from the table. So what select star from does is it retrieves all the records present in that particular table. db.test.find or db.collection name, that is test.find, does the same trick as select star from the table name. So here if you see, I have just tried to insert name lazydev, but here there is an additional field, that is underscore id. So underscore id is the primary key which MongoDB by default creates it for us if we do not specify that. If I try to specify underscore id 1 comma name lazydev, another record got inserted. db.find will retrieve us two documents. One is with the default ID that it has created for us, and second one is the ID that I provided. If I try to insert one more record with same ID, it gives an error saying that duplicate key error collections. So ID 1 is already present in the database. It will not let me create with the same ID once again. If you observe closely, the data type for the first record, ID field of first record, and the ID field for the second record are different. So that is the magic of MongoDB. There is no restrictions on the type of data you save. All you need is a proper JSON format. Each document should be a valid JSON to store in the database, and that's it. Your record will be created. One more restriction is ID should be unique. If you do not want to take that headache, you can omit the ID field and MongoDB will automatically create it for you. That's a brief introduction about MongoDB. Let's jump into our API and see what changes we can make to connect to the MongoDB server that we have just explored. Here is my API code. I did some cleanup to remove all the dummy data, and now we'll be freshly adding our code to connect to the MongoDB server. For that, I need a NuGet package. Right click on dependencies, manage NuGet packages. So here is the package mongodb.driver. The author is MongoDB incorporation itself. So we can go ahead and install this. Done. So we have this NuGet package installed in our application. Let's start writing some code. Firstly, I need some variables to hold some values. The first thing we need in order to connect to our database is Mongo client. Mongo client using mongodb.driver client. And the second thing is the database. We will see the database later. Inside the constructor, let me create client equal to new Mongo client. There are 4 different overloads for creating this Mongo client subject. First one is an empty parameter. Second one is Mongo client settings. We do not need this. Mongo URL. This is also not required. Last one is connection string. This is something which we are going to use. So from where will we acquire this connection string? Let me go back to my command prompt, exit, and once again run this Mongo command. So if you see, here is the connection string. You can copy this, paste it over here, and now with the help of this client you can connect to the MongoDB. The next thing I need is a database. So I Mongo database db equal to client dot get database. The name of the database that we created is tasks. The third thing we need is the collection. I Mongo collection. So this will require a type. Let me provide a type as to do. Here I'll create a new class to do. The first one is the ID underscore ID that we saw in the MongoDB. So the type for that underscore ID is object ID. Here it will show an error. We will just fix this error by using mongodb.bson. We need to provide an attribute bson ID to it. I'll tell you why we require this bson ID. In the command prompt we have seen that I have created a new record just by passing the name as lazydev, and it automatically created the ID for us. The same should happen here in our API. So that's the reason I am using this bson ID and object ID. It will tell the MongoDB server that this is an ID field. So once the MongoDB knows that this field is ID field, then it will automatically create that ID for us and insert in the database. So even if we do not pass ID, it will get automatically created. The second field we had is string a task name. For simplicity, I'll just use it as a name. Third one is boolean active. So once the task gets completed, we can mark active as false. So now the error is gone. Collection equal to db dot get collection, and then again this needs a type. I'll say to do. Name of the collection is to do list. Till here everything looks fine. Now let's go ahead and add some code to the HTTP post to add few records. Here is our HTTP post. It already has this to do as a request. So if model state is valid, then we go ahead and start inserting the data into the database. Collection dot insert one. We need a to do document, so we will be passing the request and done. Insert one method does not return any value. The return type is void, so we will just return created and name of add task. That's it. We are good to run our API and see whether HTTP post behaves as expected or not. Let's try this out. We do not require ID as it should be automatically generated. The name of the task is learn C#, active true by default, which is good, and execute. This is 201. Let's go back to our command prompt. Use tasks show collections. So here we can see to do list is created for us. db dot to do list dot find. Here we go. We can see our record successfully inserted into the database. The next step is to retrieve this data. Let us go back to our API. Get all pending tasks. So here I would do where result equal to collection dot find. So we have the collection over here. We need to simulate this find method. So here we cannot do just like this, open parenthesis and close parenthesis. We need to pass some kind of filter into it. So let's see. Yeah, find method is expecting a filter. So our filter would be new bson document, an empty document. So this will return all the data that is present in the database. The return type of find method is iFindFluent. We do not require such data to be returned. We need a proper data. So I'll be doing to list. Now if I see, the type of result is list of to do. So I'll just return the result object in OK. Let's try out our get all endpoint. Try it out, execute, and here is the response. This is the response that we are getting from the database. But if you observe, the ID field is a collection of different other properties. So it is an object. In the database, we see that this is a single field, object ID and some random value. But here when you see, we have this big object. So object ID is a collection of timestamp, machine, PID, increment, creation time. Obviously, we do not require such big object to identify a record. We need some simpler mechanism to identify a record. The best trick I am going to show you. Go inside this object ID. Here you can see what object ID is comprised of. It is having this object ID empty, then PID machine ID, PID machine timestamp, increment, creation time. If you scroll down a little bit, it has the capability of parsing a string to object ID. That means it can convert a string to an object ID, as well as it has the capability to convert an object ID to string. So it has the toString method. It has the parse method. We can make use of these two methods to achieve some simpler value for ID. Let's go back to todo controller and let's create a replica of todo class, and we call it as todo DTO, todo data transfer object. We don't need this bson ID. We can have a string ID here where we are fetching all the records. After to list, select new todo DTO, ID equal to e dot id dot toString, then name equal to e dot name, also active equal to e dot active. The type is IEnumerable todo DTO. Let's change this back to list and run this once again. And now we have a simpler value for ID. This is nothing but the ID present in the database. For our demonstration purpose, let's add few more records. Name would be learn Angular. This got inserted. Learn MongoDB. And now from our get endpoint, we can fetch and see all three records. Let's go ahead and implement get by ID. Let me copy this code for fetching all the records and paste it over here. We could also use toEnumerable instead of toList to achieve this operation. And then here, after toEnumerable, I'll do first or default e dot id dot toString dot equals the ID that we have passed. We have a to do record. Now let's see if result is not equal to null, then return OK. We need to map to do into to do DTO. So OK, new to do DTO ID equal to result dot ID dot to string and name equal to result dot name. And if there are no records, then no content. First, to have some records, let me fetch all the records. Now I can pick any of these ID. Let me pick learn MongoDB's ID. Try it out. Okay, I think there is a mistake from my side. Let me go back to this and try to fix this. Copy the ID, try this out and execute. And here we go, we can see learn MongoDB is retrieved from the database. If you want, I can try it out with different ID. Execute, done. If any ID doesn't match with the database, no content is retrieved. So all three endpoints are working perfectly alright. Now to implement HTTP port, we need to create one filter, and then with the help of filter we will be retrieving that particular record. After retrieving that record, we will be updating a particular field. So to create a filter, we will use builder of type bson document dot filter dot equals, and in this equals we will pass two arguments. One is underscore ID and the second one is, remember that I have shown you we have an option to parse string to object ID. So I'll be using that object ID dot parse request dot ID. This will be our filter, where update equal to builders, again bson document dot, this time update, set our field name is name, and then request dot name, and finally collection dot update one, and we will pass our filter and then our update. Okay, I think we need to change this to do. Let's see how this works. And after successful updation of records, I'll just return OK response. Put, try it out. We need the ID, so first let me run this get all records. I will try to update second one ID, and then the name would be learn Angular from lazy dev, and execute this. We have received 200 OK response from the server. Now let me just execute this one once again, and yes, here we see the response. The second record is updated to learn Angular from lazy dev. So our put is working successfully. Great. So now let's go back and try to finish this video by implementing our last HTTP method, that is HTTP delete. Here we have from query int ID. So what I'll do is I'll just remove all this old code and I would need the same filter, collection dot delete one, and this requires filter, so I'll pass this filter over here. OK response. Now let's see delete in action. First try to find all the records. Let me try to delete the last one. Try it out. Execute. 200 OK response. So the expected result is when I rerun this or re-execute this, this should return only 2 records. So let me do that. And yes, the last record learned MongoDB is deleted from the database. I'll meet you guys in the next video. Until then, keep learning. Don't be a lazy dev. Thank you.